Chicos, pues bueno, ¿cómo están?
Bien.
Perfecto. Bueno, pues el momento de la conferencia magistral ha llegado. Tengo el placer y el honor realmente de presentar a Rasmus Lerdorf, que es el creador de PHP, tantos portales, proyectos y mucha tecnología que se ha hecho en la web. Es responsabilidad y es gracias a esta genialidad que les dejo aquí, y un aplauso por favor.
Sorry, my Spanish is terrible. So I will try to not speak too fast. If I'm speaking too fast, you don't understand, please slow me down, and I will slow down. You can follow me on Twitter if you like, and the slides for this presentation are at that URL if you want to refer back to them later. This is going to be a little bit more technical than the other presentations we've had so far today. I'm not so good at non-technical talks. I'm a techie, I'm a geek. That's what I do, so that's what I talk about. But I started this stuff, this is pretty small. I started this stuff back in 1993. This is a CGI program written in C. This is how the web was built in 1993, over 20 years ago. This was not fun. This was not a good way of solving the web problem. This was a terrible way of solving the web problem. Most people switched to using something like this. This is something called CGI PM. It's a Perl module for writing CGI programs. A CGI program is basically a program that serves up a web page. So the web server would start this program, and the program would run, and the output of the program was a web page. So you can see in here it has things like an H1 call, basically, or an H1 tag. I didn't like this. I didn't want to program my HTML. I didn't want to have anything to do with HTML at all, actually. I wanted somebody else to do the HTML. And I wanted to work on the back-end code. So I wanted my HTML to look like HTML, and I wanted my code to look more like code. So I came up with something that looked more like this for the same application. So the HTML is all HTML, and the dynamic parts. We make the font. Can you zoom it?
Okay.
Can you zoom the font? Yeah, it's pretty small. No?
It's bigger than you have.
Is it? Okay, I guess I'm looking at that. Okay, alright. Now, sorry, that's me. So here we have, basically, does this shine? No. Basically, we have the HTML, and we have just a couple of real dynamic tags thrown in there. Right? The PHP tag that says, if there's a name, hi, echo name, you are echo age, years old. So this was a very, very simple way of teaching people how to build dynamic web pages. This was not simple to teach, because you have to teach people about Perl, basically. And Perl, for a non-programmer, oh, that just hurts the head. And this, C for a non-programmer, no chance. Right? Memory management and all the things that can go wrong in a C program, the web would not have happened if this is how we all had to program the web. Right? I don't think the web would have happened if this was how we programmed the web. Or if it did happen, it would have been terrible, because then only Perl hackers could create web pages. And if you've ever been a Perl hacker, you know that the web from Perl hackers would not have been a good thing. So, this was my approach to it, and it seemed to catch on with people. Especially because the web was growing really, really fast. Starting in 1994, 1995, the web just took off. And there weren't enough programmers around. In many places, it was actually the documentation team that ended up becoming the web development team, which was this weird coincidence, because a company would say, hey, we need to get on the web. And they look around going, well, what can we put on the web? This was all very new to everybody. They didn't know how to use the web. So they said, well, let's put our documentation, our product documentation, the description of our product, maybe the manual, reference manual for our product, let's put this stuff online so people can go and read about our products. And it was the documentation team that was in charge of developing the manuals and the documentation, so they now became the web team. Well, then 6 months later, they said, well, let's have people be able to check inventory and buy things from our site as well. So web team built that. And these were technical writers, these were documentation people, and now suddenly they had to learn about payment systems and databases and things like that, which was way, way out of their skill set. But this is where PHP came in. They would pick up a book on Java, and they would read the first 5 chapters, and they still had no idea how to build a website, right? Because Java isn't for the web. It's a general purpose language. You can use it for the web, but it's not that easy. And most things they picked up, there was nothing in there about how do we use this for the web. With PHP, everything you read about PHP is related to the web. So it became a natural thing. It's like, hey, I have a web problem. This PHP thing is for solving the web problem. Let's use that. And the thing I started doing around then, which was probably the smartest thing I've ever done, I didn't really think that much about it. It was mostly because the ISP that I was running my own website on was not very happy with me. I was using a lot of CPU resources because PHP was getting popular. So a lot of people were hitting my page, but it was still running as a CGI, which meant every request had to start a program to fork and exec the web server process, and it ate up CPU. This was 1994, 95, slow machines. So my ISP said, look, you're taking way too many CPU resources. I said, well, okay, I'll fix that. So I hacked PHP into the web server, which was at that time called NCSA. So I hacked it into NCSA, and I had the ISP install my web server, which was not easy to do. I had to convince him that, please, this will make the site run much faster. Later on, when Apache came along, I wrote an Apache module for PHP, so PHP could go directly into the web server to avoid the whole fork and exec CGI. So that sped up the PHP piece. But the ISP was also worried about giving people access to PHP, because someone could write a program that would need a lot of CPU. Maybe just an infinite loop, like a while true loop, just sits there, just eating CPU, more and more and more CPU. So in order to fix that, I said, well, I'll put in a limit. So we can only use up this many CPU seconds. After that, we just kill it. And I did the same for memory limits. Like if you keep just eating more and more memory, once you hit that ISP configured limit, we kill it off. So what I was actually doing that was really, really smart, which I didn't realize was very smart, was I was building the ecosystem. I wasn't just working on PHP, I was working on the environment or the ecosystem where PHP would run. So I attacked all the obstacles and said, okay, the ISP has these arguments, well, let's fix every one of the arguments. Where the ISP says, no, I won't run it, no, I won't give access to it. Go through and systematically fix each one. Security-wise, I did some strange things security-wise as well to try to address the fact that everybody's script ran as the same user. It wasn't a huge success, but the ISPs did like it at the time. But the point is that you can't just work on the one thing. Things like Ruby was around. Ruby started around the same time as PHP, maybe even a bit before actually. Python as well. but they were nowhere to be found on the web because Max, the guy who wrote Ruby, was only working on Ruby. He didn't see it as his job to sort of build an ecosystem. Nobody used Ruby. Nobody had even heard of Ruby until this Danish guy named David Hannemeyer Hansen came up with Ruby on Rails in 2003, 2, I don't know, right? That's when everybody had heard of Ruby. And all David did was he built an ecosystem. He showed how do we take this tool and how do we solve the web problem with it. And he showed via some cute videos, this is how you can solve the web problem in Ruby. And then suddenly everybody started loving Ruby, but it wasn't until someone built the ecosystem. PHP was just a bit earlier in that. And a lot of the criticism PHP gets is that there wasn't enough time spent on the design of the language, which is true. It's very, very true. I spent just as much time on the ecosystem as on the language. I probably spent more time on the ecosystem than on the language itself. I don't think, and I didn't think at the time, that the language was that important. I was more worried about building a tool that would very effectively and efficiently solve the problem. Initially, the tool was just for me. Like I said, I was doing all these things in the ecosystem because my ISP told me that they wouldn't run my stuff unless I fixed all these issues. So I fixed all these things, and I built myself this tool just for me. And other people started saying, hey, can I use it too? Sure, why not? I mean, it's just a hammer. It's not interesting. It's what you build with the hammer is interesting. The hammer itself is boring. And I've always been amazed that people find the hammer so damn interesting. It's not interesting. Programming itself, to me, is boring. I don't like programming. But I love building things. And yes, I build things by programming, but that's not, I don't program just for programming. It's like flying. I hate flying. Sitting in this aluminum tube with 400 other people for hours and hours and hours, eating bad food, bad air, bad smells. How is that fun? It's not fun. But I love traveling. I love going to places. I love meeting people. I love actually getting to the destination. The trip itself is usually pretty painful, and I don't enjoy it. To me, that's programming. I don't enjoy the programming part, other than the fact that it's a means to an end. It's simply a tool that lets me do very, very interesting things. So a bit on scale. One of the things I found was I spent a lot of time making PHP faster, and making it more efficient, and making it into the web server, doing all these things. And I found that a lot of people out there were getting confused. I was scaling up, but I wasn't very good at scaling down. Because scaling down is not a natural thing for geeks. Technical people love making things better and faster, more efficient. And that's sort of in our mind. Let's make this thing faster and better. More complicated. Complicated is good, right? Not really. But often you would think that the geeks think complicated is good because we love so many complicated things. Scaling something down and making it simple is really, really hard. And I find it's harder to scale down than scaling up. Scaling something down so that anybody can understand it, just by you talking to them for 30 seconds, is oh yeah, I understand that. Some of the Java-based application servers back in the early 2000s were horrible for that. I worked for IBM for about 10 months. I was on the WebSphere team. If any of you have ever used WebSphere, oh my goodness. I'm a reasonably intelligent person, and I understand the web. I was kind of part of the early days of the web. I wrote parts of Apache. I wrote a lot of the infrastructure of the web. But WebSphere, it took me about 5 weeks before I had my first Hello World application using using WebSphere. The amount of books I was reading, like, oh wow. And that's why I didn't last very long with IBM, because I just didn't understand it. It was too complicated. Like, look, I'll go back to my little PHP thing. I can understand that. This WebSphere thing, that hurts my brain. IBM did a horrible job of scaling down WebSphere. And most of this room have probably never heard of WebSphere, for good reason. So, from a robustness perspective, one of the things I always didn't like about WebSphere and Java in general is having to worry about threads and also a garbage collection. And combine the threading and the garbage collection, and you never know what the threads are doing when garbage collection kicks in. It was just too complicated. I always avoided threading in PHP for that reason. We don't need threads to eat up CPU, to use all of the CPU, because the web is inherently concurrent. You just have more web server processes who end up using all the CPU resources. And you don't need threads for concurrency, because event-based things usually are more efficient anyway. So I always avoided threads. And I really pushed for the forking, single process, single request, free forking model in Apache. And I always pushed PHP towards the non-threaded version of using it for that reason, for robustness. Another thing I was playing with at the time, for the ecosystem, you need 4 things. You need an operating system, and I was using Linux, Xenix before Linux, but Linux when Linux came around. Apache, because I helped write parts of that. MySQL didn't exist back then, so I was using a database called MiniSQL, written by a guy from Australia named David Hughes. It was a cool little database, a bit like MySQL, more simplistic. One of the things I found, though, was sometimes by mistake, I would do a select star, and I would get 100,000 records. And these would all have to come across TCP/IP, across the wire, and I was sitting there for many seconds waiting for all the data, and then I would show the first 10 on the web page. You're not going to show 100,000 records on the web page, right? That was very inefficient. And I didn't know a lot about databases. I didn't know that there was such a thing as cursors. And MiniSQL didn't have cursors. So I came up with this limit clause, right? So you just put at the end, select star from whatever limit 10. Just give me the first 10. And I hacked that into this MiniSQL database. And that's one of the very amusing things, I think, of my early hacking, is that this limit clause has now been copied into MySQL, into Postgres, into Sybase. Many databases now have picked up this limit clause. Even databases that already had cursors that let you do the same thing, limit is just a natural way of doing things. I did get a lot of complaints from database geeks saying this is not ANSI SQL compliant, did you not read the spec? I didn't know there was a spec. There's an SQL spec, really? That seemed foreign to me because every SQL I've ever seen was different. But not too many people know that I did the limit clause, so I'm somewhat safe on that. So a few common criticisms along the way. People always bugging me about naming inconsistencies, for example. People say PHP is really ugly and very inconsistent. Not really, it's just not consistent the way you expect. It's consistent vertically in the sense that PHP is a very thin layer on top of hundreds of underlying libraries. And for speed of development, we have just tended over the years to simply map the underlying library function names one-to-one to the PHP names. So if you looked at the libmysql client API, for example, what you see in the C API or the header files is pretty much exactly the same function calls and arguments in argument order as you have from PHP. Same with OCI8 for Oracle. So if you're an Oracle geek,
starting to do PHP with Oracle is super, super easy because you just use all the functions you already know. So in that sense, PHP is very consistent vertically. If you take it from the underlying library all the way up through the stack, it's completely consistent. What people complain about is that it's not consistent horizontally. So the Oracle calls don't look like the MySQL calls, don't look like these calls, because we never did sort of a grand unifying design that says everyone must program things this way. Because PHP grew organically, very slowly, people were adding things that they knew about. So Oracle geeks added Oracle support. And it just felt like a natural way of doing things. And yeah, it might have been better if we had slowed down and waited and designed more. But then I don't think it would have happened. And then a lot of technologies that got built early on top of PHP wouldn't have happened either. So I don't think I would have changed anything. A few other small details up there as well. And if you're particularly interested in one of them, I can give you a long story on any one of these things. One very common criticism is the argument order on array and string functions. That the array, haystack needle is switched between the two. But it's actually consistent. Every single array function is needle haystack. Every single string function is haystack needle. But you didn't know that. All right, let's get into the present a little bit. The current version of PHP that's out there is PHP 5.5. If you're not on it yet, I would seriously recommend, if you're using PHP at all, I would really suggest that you start looking at moving your stuff to PHP 5.5. Main things we did, we added an opcode cache directly to PHP. Previously, people would have to install that separately. An opcode cache is simply a cache that sits between the compiler and the executor. So PHP has a compiler that takes the script, reads the text file, and then turns it into a set of opcodes, kind of like the machine language of PHP. Then these opcodes can be stored in shared memory, which is what this opcache does. And then the executor can simply execute directly out of shared memory. So you can have your entire website and all your PHP scripts in memory and never have to touch the disk, which speeds things up a lot. Nested calls are a little bit faster, so if you have recursive, a lot of recursive code will be faster than 5.5. Generators, new feature in 5.5 as well. Basically, the new thing is this yield call you see there. Every time you call a function, it'll yield the next value of the sequence. So basically, it maintains the state. Right? So the state it was in, so the values of the variables all will be maintained, and it then yield the value of $I at that point. And every time you call it, it's going to yield the next value in that loop. It's kind of very simple to understand. It's a way of, instead of writing a function that builds a huge array and returns the entire array, which uses a lot of memory, this is a way of just getting one element at a time without having to, but still having a function call so you can have clean code. So by using a generator, you can have low memory usage, clean code that builds interesting iterators. What's a little harder to understand are coroutines. Coroutines and generators go together in the sense that a coroutine also maintains state, but the communication is the other way around. Instead of a generator returning something, a coroutine, you send something into it, and it maintains state. So you can pass things into these function calls, and they'll maintain state across multiple calls. So they're called coroutines because you can have many of these, and they'll each maintain state. So you can essentially get cooperative multitasking that way, in that you have many different states that are kept. And when you send new values to each state, you're basically sort of moving along each of these routines. Each of these coroutines get moved to the next sequence. I can't explain coroutines fully in 15 seconds here. If you're interested in them, I highly recommend going to the talk and clicking on that link. There's a very, very informative article on coroutines in PHP there. There's a finally clause now in 5.5. Basically, if you're in a try-catch, if you want something to always happen, no matter whether an exception happens or not, any sort of cleanup you might need to do from those set of calls, you can toss them in the finally. Finally ensures that anything you put in there will get executed, whether or not there was an error. Minor feature, you can do the first level dereferencing right in for each by using lists. Not super useful. Constant array and string dereferencing, also not super useful. I'm not sure why you ever need to do this, but it seemed a bit inconsistent that we didn't support it. Empty can be used anywhere now, basically on any returns from functions or expressions. You can apply PHP sense of emptiness to it. We've rewritten the curl upload functionality because it was terrible before. Now it's a lot less terrible. And we have a very simplified password hashing API now. This is one of the scaling down things. What we saw was that people are terrible at understanding cryptography. We've seen website after website getting hacked and having their password databases leaked. Some of them had stored passwords in plain text. Others had used very bad hashing, or hashing without a salt, or hashing without enough work, basically, in order to break it. And if you hash without a salt, there's something called rainbow tables. So a rainbow table is a bunch of pre-calculated hashes. So you basically take every word in the dictionary and every other word you can think of, and you hash it. So you know all the hashes, and that's a rainbow table for that type of hash algorithm. Then you just compare the hashes to the password databases out there. And it's extremely quick. You can break hundreds of thousands of passwords in seconds using a rainbow table if you can get access to those hashes. And the ISP, or the service, didn't use a salt. So, by scaling this down so that any idiot, as long as you simply call password hash and password verify, PHP will pick same defaults for you. It'll pick decent salts, and it'll do all the right things, even if you don't understand how cryptography and hashing works. You will get it right. If someone steals your password database, they're going to have a lot of work breaking those passwords. You can read all about migrating to PHP 5.5 at php.net migration 5.5. What we're currently working on is PHP 5.6. We released the first beta 2 weeks ago. One of the initial features is variadic functions. Basically, this is the same syntax that the next version of JavaScript or the ECMAScript standard will use. The ... is the variadic operator. And it basically says, for this particular function, it's a query function that says, say, put the first argument into $query, but then put all the following arguments into an array called params. So it's a way of doing variable args, function calls, in a much neater way than bar func calls, stuff like the other functions we have to do that manually. This is a syntactical way of doing it very, very nicely. Plus it supports references cleanly. The other side of variadic functions is argument unpacking. So on the caller side, you can also basically unpack arguments directly. So in this case, if we have a test function that takes 6 arguments, so it's just a regular defined function with arg1 through 6. It's defined to take those 6 arguments. From the caller side, you can use that same variadic operator. So if we have an array with 3 elements and another array with 3 elements, you can just pass them ... array 1, ... array 2, and they'll get unpacked, and it was as if you passed in 6 arguments directly. And there are a lot of times when this is quite useful, especially for frameworks, where they have lots of complicated things. They don't necessarily know the number of arbs. We've also improved the constant scalar expressions. So the compiler can now do simple math and simple operations at compile time. Whereas before you could only put constants. You could just say A equals 1 or A equals a string. You couldn't do any sort of math, a bit shift or anything like that. Now you can. We've also added a power operator. It's a right associative power operator. Meaning that last example, -3 to the power of 2, most people will say, hey, that's wrong. That the output, sorry, not the last one, the second one there, that the output should be 9, not -9. But it does the power before the negative. So it does, here it does 3 to the power of 2 times -1. And that's actually how every language in the world does it. Python, Ruby, C, C#, everybody, actually no, I think C# is the one exception. But every language except C# does it this way, so we follow along. Basically, if you don't know, if you're not sure, just put brackets, put parentheses around it, so that the poor person reading the code will have a chance to understand what's going on. We've also added internal operator overloading, meaning you can now do things like this. So you can initialize using GMP. GMP is an arbitrary precision math library that does math in strings, essentially. So you can have infinite precision in this math, whereas the built-in CPU-based math registers are only 32 or 64 bits wide, and you end up losing precision. With this, you go way, way slower, but you can do amazing things. And with the internal operator overloading, you can now simply do GMP init, and then you can use the normal multiplication, division, addition operators, where before you had to do GMP add and GMP mult. Now you can just multiply directly and we'll figure it out. So use function, use constant, so you can now bring in functions and constant into namespaces, not just classes like before. And a bunch of other things, a lot of it around SSL. Given Heartbleed and other things, we've been spending a lot of the time on beefing up SSL support in PHP. So if you're doing anything SSL related, you might want to look at PHP 5.6. Lots more crypto stuff, SSL stuff. You can now do asynchronous Postgres connections. Prior to this, it was only MySQL that was supported for asynchronous queries. Now you can do asynchronous queries against Postgres as well. So you can fire off 6 different queries, and then they all operate in parallel, and then you can collect the results in parallel. Support for greater than 2 gig file uploads. Not sure how many people actually do greater than 2 gig file uploads, but now you can. And a bunch of other things there. Actually, the hash compare one is interesting. Hash compare is a timing attack safe comparison function, which to most of you means absolutely nothing. But timing attacks are really, really cool. When a computer compares 2 strings, so let's say at the password, let's say your password is banana, and someone guesses apple. The computer will compare the first letters, A and B. Hey, they're different? Stop. Wrong password will be output. But what if the guess was BAN? So the computer is going to compare the B's, and says, okay, BB, that equals, AA, that equals, NN, that equals. Oops, on the 4th character, it doesn't equal, fail. But that took a little bit longer, because it ended up comparing 3 letters. And if you time this very, very carefully, if you measure how long it takes for the login to fail, you know how many characters you got right. And if you know how many characters you got right, it greatly reduces the number of times you need to try. Because if the password is banana, and you tried banan with the missing A, without a timing attack, this banan guess was just as wrong as apple. But if you time it, you know that, hey, banan was close. I'm going to guess more along the lines of banan because it's close to that. And I'm not going to guess anything related to apple anymore. So you can reduce the guessing from like hundreds of millions of guesses down to like 10,000 guesses. And that's a huge, huge advantage if you can cut the number of guesses you need by a factor of whatever. 3 orders of magnitude sometimes. So, it's something a lot of people aren't that aware of. But if you're writing any sort of sensitive algorithm, any sort of password comparison type thing, you should be using a timing attack safe comparison. And that's what we've added now in PHP 5.6. It's not that hard to write it in user space. You simply need to just make sure you compare all the letters. Even though you know the first letter doesn't match, you need to compare all of them all the time so that the timing doesn't give away any secrets. All right. As before, you can read more about migration to 5.6 at php.net, migration to 5.6. You guys are all excited about timing attacks up here. All right. Next topic, a little bit less technical, but still quite technical, so sorry for some of the non-technical folks in here. One of the things I've been noticing is that we, as a community, we're terrible at deploying our code. We're really not good at it. I think every single startup in Silicon Valley I've ever visited had their deploy system completely messed up. Or even if it's technically correct, it's so slow and cumbersome that people hated deploying, and they were afraid of deploying. So I work at a company called Etsy, out in New York now. And one of the things Etsy does is we deploy 40 to 50 times a day. So we push new production code to our website 40 to 50 times a day, every single day. Well, not Saturday and Sunday. Saturday and Sunday, there might be 1 or 2 pushes for emergency fixes, but other than that, nothing there. But if you push 50 times a day, you better be damn sure that your deploy mechanism works well, and that no requests are lost, you don't have the site slowing down, basically you have no impact on the performance of your site. So you need a deploy system that can do that. And it's actually really, really simple, but for some reason everyone gets it wrong. So the problem we're trying to fix here is if we have a request that's in process, and on a busy website there are always requests, right? There's no time when there are no requests, unless you shut down the website, but you don't want to shut down the website because that's terrible. You can't put out the little thing, sorry, maintenance. Well, sometimes you have to, but you can't do it 50 times a day, because then your site will never be up, right? So, you need to solve this problem. What happens when you deploy in the middle of requests? You obviously can't just push new files into your document root directory, because there are requests currently reading those files. So, you have a bunch of things you can't do. You can't copy the files directly into the document root. You have to let existing requests finish on the version of the code they started on. New request coming in needs to start on the new code, because if they start on the old, they'll never get to the new. At some point, we have to switch them over to the new. Personally, I don't want to clear my output cache, because that slows down the site. I want minimum impact on the site itself. So I needed to build a system that solved all of these, that met all of these conditions. So the way that I did it, and many people do the first part of this, is that they create a new directory on their server, and they send all the files, the new version of the site, to this new directory. And no requests are hitting this directory yet. Then once all the files are there, they move a symlink across, so that the actual document root is just a symbolic link that then gets pointed to the new directory. And this is where most people stop. But what they miss is that you can't just switch the symlink, because there are requests reading from that document root that you have defined. If you just flip the symlink, they're now going to follow the symlink to the new document root, and the next include is going to be the new version that's going to be out of sync with the request that, or the version that the request started on. You have to be able to run two versions of your site at all times concurrently in order to solve this problem. And the fix is actually really, really easy. So we flip the symlink, but what we end up doing is we do a real path on the symlink. And that's the one little trick that I don't know if I came up with it uniquely, I probably didn't, but that was the way I thought to fix the problem. So what happens is that this web root is a symlink that nobody really knows about. The web server knows about it, but what I do at the web server level is I do a real path. So I look at the target of the symlink, and I say, the target is now B, and I set the document root to B before the request starts executing. So as far as the request is concerned, the document root is B. It doesn't know about web root at all. The document root for the request is B. If I flip the symlink, it doesn't matter because all it knows about is B. It knows nothing about web root. It's not looking at the symlink because I fixed the symlink right. I dereference and I find the target of the symlink at the very top of the request. So, the easy way to do this, in Nginx, it's actually built in. You can set your document root to something called real path root, and it will do a real path. It will dereference the symlink, and it will set the document root to the target of the symlink. Apache doesn't have that feature, so I had to write a little module for it. It's called mod realdoc. You can find it on GitHub. That does the same thing. It looks at the symlink, and then it sets the document root to the target of that symlink. That way, when the request starts on the document root, A, it's going to continue on A until it finishes. And only new requests will hit B because it's only the web server that can dereference the new target for the symlink. The requests themselves never look at the symlink. They only abide by the document root that the web server tells them. So, if you want to read more about that, there's a Codeless Craft article. If you just search for atomic deploys in Etsy, you'll find it, but it's Codeless Craft, that URL. And I think more sites need to do it that way. Alright, I see a lot of blank faces out there. Let's talk a little bit about more non-technical things. Like I said at the beginning, I don't actually like programming. That might be hard to tell because I'm obviously a geek. I'm up here spewing all kinds of very complicated technical stuff. So I must love programming. No, it's all wrong. I love solving problems. Yes, I know how to use a hammer. I don't love my hammer. So, I fall more in the dreamer side of this little chart. To me, there are sort of three types of people, right? They're the dreamers, they're the hackers, and they're the coders. The coders are the people who just don't care what they program. They love programming for the sense of programming. They couldn't care less what the code does in the end. As long as it's beautiful and it's just the algorithms are neat, they'll go home and they'll study algorithms and they'll brag to their friends about this amazing new algorithm they came up with, a new way of solving this one particular algorithmic problem. In the end, their code might be missile guidance systems that kills people, but they don't care because the code is beautiful, right? I could never work like that. If I knew my code killed people, no way would I write that code. But coders are very, very single-minded, focused on coding. On the other end of the spectrum are the dreamers. I get approached all the time by business types that just need a technical co-founder. Just, right? They have this great idea. They just need someone who can figure out how to build it. Ideas aren't worth very much. Seriously. Think of, let's say, planes. I have an idea. Let's make planes fly 10 times faster. Great idea, right? I mean, everyone would like to get places 10 times faster, especially me. I hate flying. If my trip to Mexico City from San Francisco was 20 minutes instead of 4 hours, great. Awesome idea. There's just one small little detail. We need to build a plane that can fly 10 times faster, but that's just that. I just need a technical guy to help me. Right? My idea is awesome. So, it's always the implementation that where the real technology, where the real insight is. It's how to actually solve the problem. It's one of the big reasons I hate software patents with a passion. Because most of these goddamn software patents are just like that. Let's build a plane that can fly 10 times faster. And that's it. They just write it down on paper, file it to the patent office, and they're done. They move on to the next patent. They haven't done anything. Most of these software patent ideas are completely obvious. It's not completely obvious how to implement it, but it's completely obvious that we would like some of these things one day, just nobody has figured out how to build it. And then when the poor guy who figures out how to build it 20 years later actually does, then the guy with the patent says, hey, that was my idea. Bullshit. That wasn't your idea. You didn't know how to build it. So ideas without any sort of basis in reality are worthless. Where the real interesting thing is in the middle there. The coder, who's also a bit of a dreamer. So if we go back to the airplanes, if you actually have a degree in fluid dynamics, aerospace engineering, if you actually understand how to build a plane, and you say, hey, I have an idea, I can build a plane that's 2 times faster because I'm going to use these materials, I'm going to do it this way. That's a real idea, that's a real thing, that's realistic. And it's not just a stupid software patent, it's actually feasible. And that's where innovation comes from. It comes from that middle section there, where the people who know about the technology but can also dream a bit. Personally, I fall a little bit more on the dreamer side than the coder side. I dream way more than I code, which isn't always good. Some of my code is absolutely horrible. But the idea was pretty good. And I knew just enough about coding to actually build it. I didn't have a clue how to build a programming language when I started PHP. And most of the critics out there said, yeah, we can see that. Right? And yes, that is true. But all these damn critics, they didn't build it. There are all these PhDs in computer science that send me nasty emails all the time about all the stupid things I did in PHP. I was like, well, what did you write? And does anyone use what you wrote? No. Like, okay. So obviously you made a few mistakes as well, because in the end, your code is useless. Nobody uses your code for anything. Yes, my code is a little bit ugly, and yes, I made mistakes. But guess what? It's useful code. Useful being defined by the fact that it's in use by a lot of people. And they tend to not like that argument. But I like it. I like the fact that some of the software projects that I see out there, one of my favorite ones is called Sahana. It's a disaster management system. Basically, it's a way of very, very quickly putting up an IT system when a disaster happens. So it keeps track of missing people, for example. So there is an Android and iPhone app, and there's a service-side database system. So if you find someone, you bring them to a shelter, you ask them their name, and very quickly type in, say, I found this person, she's in this shelter. And the family can look up on the website and say, hey, I lost my grandmother, where is she? And very quickly say, oh, she's over in that shelter. That's amazing. And the same thing for coordinating relief efforts. So when an airplane full of diapers shows up, there's someone there with an app that says, well, okay, we have diapers at this airport. And when someone needs diapers, they'll say, okay, well, where are the diapers? And they can very, very quickly, using the system, they can coordinate all these different efforts. And a lot of these disasters happen in countries that aren't very prepared. Haiti had no such system, obviously, right? A lot of countries didn't have a system like this. This project was started in Sri Lanka because when the disaster happened in Sri Lanka years ago, they didn't have it. And the geeks there said, oh man, if we had had this disaster could have saved, or we could have saved a lot of lives. Or at least made a lot of lives less miserable. So they did it. They were dreamers, they were hackers. They said, hey, well, we can build it. And these Sri Lankans built it, and it's now been deployed in 30 different disasters in many different countries over the years after that. To me, when people criticize PHP, that's kind of what I go back to. I don't care. They built Sahana using PHP. I don't need anything else. It saved, even if it just saved one life, that's enough for me. Now, there are plenty of things I'm not super proud of that's built in PHP as well. But I try to focus on the positive. If you don't focus on the positive, you have a miserable life. This was me. So, I grew up in a little place, this little house, in the northern part of Greenland, which is quite far from where we are today. This is actually a recent picture. You can see all the other houses around. It hasn't changed. So I grew up, I was born in 1968 in that house, and this picture was taken, I think, in 2003. Very little has changed. There are no other houses. The main city is down there. This is kind of looking down from the house. And back then, I think there were around 200 people in the city. It has grown a lot. There are 500 people now. Which is a little crazy, being in Mexico City. 500 people. You take 3 steps and you pass 500 people here. This is downtown. So this was in a place called Disco Bay. And the island's called Disco Island. D-I-S-C-O, yes, in the 60s. A lot of glaciers terminate in this bay. So all the icebergs end up breaking off and floating down the coast of North America, come out of this bay. And every single day you see icebergs floating by. So those pictures have absolutely nothing to do with PHP, other than the fact that there's a big world out there. There are a lot of people that don't have internet. There are a lot of people that are basically disconnected from the world. So many things happen on the internet these days. So many people are not part of it. I think we can fix that as a community. Yes, the internet access, part of it's going to need some big pockets. It's going to need the Microsoft, the Googles, the Facebooks of the world to actually come up with a way of getting internet access. To someone told me 55% of people in Mexico don't have internet access, right? That's a lot of people. But I think it's a problem that we can solve, and I think there's a lot of money in solving it. One of the big problems, though, is that we tend to work on stupid things. We tend to build systems, and the venture capitalists tend to fund things that don't really matter. If half the startups in Silicon Valley disappeared tomorrow, the world would not be worse off. Most of the things Silicon Valley startups are working on are completely irrelevant. They don't make the world a better place. Their only goal is to make the lives of the 2 founders much, much better, right? By selling out to a company. They're not out to improve the world. That hasn't always been the case. Used to be Silicon Valley investments were very much longer-term oriented. And technical people tended to work on longer-term things as well. There was this gold rush that I think has really skewed our industry in the wrong direction. And it's such a lottery. Out of millions of developers, you'll have like 4 guys that make tons of money, and the other folks are just working their asses off for nothing. Really. We should be working our asses off for nothing while making the world a better place. At least something positive comes out of it if we do that. Plus, I still think there's a lot of money to be made by bringing technology and internet access and services that are actually useful to the 55% in Mexico that don't have access. So I've been working on a project that tries to address this. And one of the things I realized is that I've run out of things to solve just by typing on my keyboard. The things I can solve simply by typing are easy. If I can program it, it's a trivial problem. Yes, lots of programming gets a little bit complicated, but compare that to dealing with a Mexican government official. It's really, 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 really hard to convince this government official to change the way he sees something, if it's not in his own best interest. Same thing goes in Africa and many countries, even the United States as well. Trying to go in and change the views of the people in charge in order to make the lives of the people that he's supposed to represent better is almost impossible. I had to deal with a few government officials in this project I was working on, and I dreamed of getting back to my keyboard where I could just tell the computer what to do, because this whole government official business was horrible, absolutely horrible, trying to get anything done. That's a hard problem. Programming is trivial. So I was trying to get Etsy into Mexico. Not into Mexico City, not to you guys. You guys already had Etsy if you wanted. You have an internet access, you have smartphones, you have a bank account, you have all these things, you know how to ship things, although shipping in Mexico, shipping things up and into Mexico is kind of hairy still for everyone. But I was trying to go out to people who didn't have internet access, like this guy who was making these amazing pottery dishes, like the one he's holding, which he was selling for under $10 to some distributor who then took it and resold it in the United States for $300. And this is exactly what Etsy is trying to fix in the developed world, in that sense that you can sell directly. If you know how to make plates like this, you can put it on Etsy and you can sell it directly to rich Germans or rich Americans who will pay $300 for your plate. Etsy takes like a 40-cent listing fee, but that's 40 cents out of $300. It's not $290 that the middleman took. And we can do that because of scale. We have tons and tons of shops. The middleman can't do it because he can't really scale, because it's just him traveling around, right? But this guy's life would be a lot better if every plate he developed, he could sell for the full $300 instead of $10. The entire economy of this little town could be changed. If I could solve he doesn't have internet access, he doesn't have a bank account, he doesn't know how to ship anything. Those are kind of hard problems to solve. There are ways around some of these things, and I'm still working on it. We've been working on a smartphone app where you can manage your entire shop just from your phone, so you don't need an actual internet connection. You have a smartphone connectivity, which they tend not to have also. But at least we're ready for the point when he does get a smartphone. We're there. We have a reason for him to get on the internet. And he has a huge reason to get on the internet. If we can teach him that he can sell his plates for $300 instead of $10, his incentive for connecting to the internet is going to be huge. And then he has enough money, and he now has an internet connection. He's the next Facebook account. So Facebook should be helping me do this. Or Microsoft should be helping me do this. The larger companies should have a big interest in helping companies like Etsy and others as well that provide really tangible reasons for a potter living on a farm in the middle of nowhere for him to get internet access. And his kids, if he has internet access in the house, his kids are going to be growing up with internet, right? Their lives are going to be different as well. So that's what I mean on try to work on things that matter. This is kind of a grand scale things, and I don't mean to preach, although I am a little bit. Find things that truly matter to you. I mean, what matters to me is completely different to what matters to you. Try to find things when you honestly look at it yourself. Is the stuff I'm working on, does it actually matter? Can I do something different? Are there companies I could work for where what they're doing matters a little bit more? And I mean, if you're having trouble putting food on your own table, that's obviously the problem you have to solve first. If you get to the point in your life where you have a choice, you can choose between 10 different job offers, look at what the companies do and talk to them and ask them. That was why I joined Etsy. I asked them, look, I want to work on this. And Etsy said, yes, great. If you join us, you can work on all you want. And that's why I joined them. Because I did have a few job offers from other companies too. But I joined this little startup because they let me work on something like this. Okay. I have no idea how I'm doing this.
You're okay. Do you want to say something else?
No, questions. I want to leave a little bit of time for questions. Usually there's quite a few interesting questions.
¿Alguna pregunta que quieran hacer? ¿Algún comentario? No tengan a lo mejor temor por el idioma. Si la quieren hacer en español, ahorita ayudamos a que la traduzcan al inglés e igual la respuesta para que puedan tener un poquito más de confianza.
Or you can ask in Danish.
Excuse me, it was with the doc type difference that PHP has when you could change that Apache doesn't have. When you do the doc type page, when you wanna.
You mean on the deploy?
Yeah, why hasn't that been?
Why isn't that part of Apache?
Yeah, why hasn't it?
I don't know actually.
Modified? As an
I'm not sure why Apache doesn't have a built-in mechanism for doing that. It seems like an obvious solution to the problem. I'm not sure. I'm not sure why Apache did that. I didn't think of it until 2 years ago myself. Right? So that's what I was saying. I don't know if this is a new thing or if other systems out there do that. But I worked on Apache myself, and I didn't think of this 15 years ago when I was doing Apache work. So maybe simply nobody thought of it. Although Nginx did think of it. So, but Nginx has all kinds of interesting features. This one I found randomly by going through. Hey, it already does it. Because I started writing an Nginx extension to do this, then I stumbled across it when it's already there. But no, honestly, I don't know why Apache doesn't have it.
¿Quién dijo yo?
Otra pregunta, lo que sé en español. In which moment it occurred to you PHP?
So the question is basically, how did I think of PHP, or how did I come up with it? It wasn't really a Eureka thing, it was simply, I needed it. Like I explained, I didn't like the other ways of solving the problem, and I had a specific use case in mind. I wanted my HTML to just be HTML with just a few tags. For the first 3 years, I didn't consider PHP a language at all. It was just a templating system. It was a macro templating system that just, you put in a little macro, and the way I thought people would use PHP would be as basically an API to write against, to write C code against. Because writing any sort of complex application in a loosely typed language is crazy. You need strong typing, right? That C has. I thought PHP would be a way for people to write their C applications without having to write all the boilerplate code. But that turned out not to be the case, obviously, because people hated writing anything in C. So they just wrote everything in PHP, and to me, that's just really, really crazy. Some of the things I've seen written in PHP, oh my goodness, I'm surprised it works at all. The amount of complex code that they put into my templating system is insane.
¿Otra pregunta? ¿En español y en inglés?
It's one of the last days.
What's the future of PHP? Are you planning to do a full object version of the language?
So we're not going to pull a Python 3, if that's what you're asking. Basically, we will continue growing the language incrementally, like you saw the new features in PHP 5.5, new features in PHP 5.6. Once we do a next major release, there'll be some major features, but we're not going to break backward compatibility, at least not on the grand scale. There are things that we have broken. There are functions we have removed. There are certain types of things that we do change slowly. We'll put in a deprecated warning in one version, and then 2 versions later we'll finally remove it. But we're going to continue along that path. There's simply too much code out there written in PHP for us to come up with a new language and try to convince people to jump the gap to it. Because that's really, really, really hard to do. Because Python is trying to do it, they're having trouble. But I think they will get there. Their user base is smaller and generally more technically aware. PHP's user base is quite a bit bigger in terms of the number of lines of code out there. Plus, the PHP user base is not as competent. Now, I don't want to insult, it's probably a bad thing to say, but it's just, a lot of people use PHP because it just works, right? They'll install PHP, they'll install WordPress, it just works, perfect. They don't want to deal with the details of doing an upgrade like that. Whereas a lot of people who use Python are more involved in the actual Python code themselves, and there's a greater chance that they'll take the Python code and convert it versus the average PHP user. Now Python has realized that that's not happening quite as fast as they thought. I saw Guido just announced they're going to support Python 2 until 2020 now. It's a long time. So no, we'll continue sort of along the path that we've been going. Expect some big jumps in the major versions, but nothing earth-shattering.
Okay, so I think we have time for another question. I'm here.
Okay.
Otra pregunta más, una última pregunta. ¿Nadie? Well,
There's one up.
okay.
This is quite a very interesting talk that you're giving us. I saw one that you gave on Veracruz 10 years ago.
10 years ago.
10
Wow.
years ago.
Okay.
I don't remember.
I remember being in Veracruz, yes.
Yeah.
I remember my talk.
And it's very interesting because 10 years have come and PHP right now is like the biggest language used on websites. And it's a bit, as you said, it just works. And then you were you just moved to Yahoo on that time. So it's very interesting how things have come 10 years from that point. I don't know if that was the first time you came to Mexico.
Maybe.
Probably.
I think maybe I've been to Cancun before that for a conference.
Okay.
Maybe. I've been to Mexico before for personal reasons, like vacation and stuff. But yeah.
Yeah, but
It was one of my first conferences, that's for sure.
Probably, exactly. And the question is that the point that you are making is very interesting for all the people that is working with technology. We have to face more this entrepreneur technological side, but on the dreamer, on the middle of the dreamer and the coder, as you put it. And I myself consider also that way. What's your advice to, you already gave some advice, but what would be another advice to all the people that are starting to work on entrepreneurs with technology, mainly based on Mexico, on third world countries, as you mentioned? What would be your advice?
So, unfortunately, a lot of it hinges on funding. And I don't know what the venture funding climate is in Mexico. I suspect it's not very good.
It's not good. In the end, you rely a lot on bootstrapping.
Right.
On the bootstrapping that you can get from your own work.
Yeah.
You do. I'm an SAP consultant.
So if you can't get any sort of outside funding, that does limit you quite a bit.
Yes.
Although, on the other hand, there are so many cheap services now these days. I mean, your entire technology stack is free. Even your infrastructure via like Microsoft Azure and Amazon Web Services are not super expensive. So you can actually bootstrap pretty far, technology-wise. The problem is people, usually. So how do you convince 5 other people to buy into your crazy idea? Now, that's where funding helps in Silicon Valley, because you can basically buy the coders. The coders who don't care about your idea, they just love to code. Pay them enough money, they'll code whatever you tell them, right? That's how a lot of startups work in Silicon Valley. If you don't have funding, you don't have the coding muscle behind you. That becomes really, really hard to get going. And it means it takes longer. You can do it yourself, obviously, but your time frame gets expanded. If you can throw 10 good coders at a problem, 3 months later you have a product, right? If you are only doing it in your spare time, 3 years later you might have a product. And the window might have passed you by, right? That's why the Silicon Valley funding machine is so effective, is that from an idea to a product, 2 to 3 months, and you're out there, right? Other parts of the world, you might have exactly the same idea before Silicon Valley geek had it, but you just cannot execute fast enough because you can't buy the hired guns that can churn out code at that rate. So I guess this is terrible advice because it's very negative, but I don't know how to solve that. If you can solve the people problem, if you can go into a university maybe and then trick a couple of smart geeks, computer science geeks, into working on your idea, then you have something. But it's tough. They really have to buy into your idea, and it's hard. It's hard to be that convincing on something unproven.
Thank you.
Ok, bueno, creo que nuestro tiempo para las preguntas ya está agotado. I think that our time for questions is over.
Okay.
But before we move to something else, I would like to ask you a last question.
Okay.
Maybe it's a little bit personal, but I think that the most important thing that you said today is to do something that really matters. My question is, do you think that you're doing something that really matters, or are you still looking for it?
I'm trying to do something that really matters. PHP doesn't matter. It's a hammer. Hammers don't matter. There are lots of hammers in the world, right? It's what you do with that hammer. If I could get that potter here in Mexico, if I could get him online, if I could get him selling his pots for $300 instead of $10, then I've made a difference. Now, I think I have mattered indirectly. Like the Sahana project, for example, I provided the hammer that they used, but that wasn't me. Right? That was them. They did something that really mattered. I was kind of indirectly in part of it, and I like to talk about it, but it wasn't me. So I'm still looking to do something that matters in that case, because so far, all I've done is build hammers. Hammers are not fun. They really, really don't matter.
Okay, thank you.
Thank you very much.
Damas y caballeros, Rasmus Lerdorf.
Remember surprise?
Surprise. Wow.
Yes, yes.
See?
Is
directly. Oh, thank you. Muchas gracias por venir a la ciudad.
Thank you for the audience for showing up.